Okay, so in this video, let us get a feel of Coulomb's force as a conservative force. So let's take 2 point charges and both of them are at rest initially, and let's say they are separated by an infinite distance. Now let us fix the charge A so that it does not move, and let me apply a force to bring the charge B to the point Q, which is near A. Now then I would have done positive work on charge B because my force direction and the displacement of the charge B are both in the same direction. So the whatever positive work I do on the charge will then get stored as the potential energy of the charge B at point Q, and let's say that is Y joule. Now if I remove my restraining force, then the Coulomb's force of repulsion acting on the charge B will push the charge away and the charge moves to the right, gaining kinetic energy and losing an equal amount of potential energy. And what we will find is that at any point on the trajectory of the charge B, let us say here, here or here, the sum of the kinetic energy and potential energy of B remains constant. That is the same Y joules. That is, the sum of kinetic and potential energies is conserved. So when charge B is moving under the influence of Coulomb's force, the sum of kinetic and potential energies of B is conserved at any point in time. Now forces of this kind, like the Coulomb force here, are called conservative force. So Coulomb's force is a conservative force. Now on the contrary, just to give you a contrasting example so that you can differentiate and understand it better, when a block, let's say of wood, slides on a rough horizontal floor, the force of friction between the block and the floor acts in the direction opposite to that of the motion of the block, and that retards the motion of the block, and the block finally comes to rest in some time. Now all its kinetic energy gets lost, most of it becomes either heat or sound, and the sum of the kinetic energy and potential energy does not stay constant. So here the force of friction then is not a conservative force. Okay, so let's recap. So why is friction force a non-conservative force? That is because when the body moves under the influence of the friction force, the sum of its kinetic energy and potential energy does not remain constant. And why is Coulomb's force a conservative force? That is because when the charged body moves under the influence of the Coulomb's force, the sum of its kinetic energy and potential energy remains constant. That is, the sum of Ke and Pe is conserved.